Now, in our last lesson, we took our first giant leap into object-oriented programming. We've learned the difference between a class, which is the blueprint, the object, the actual thing. But now a car is more than just a list of parts. A book is more than just a title and a page count. So real-world objects can do things. A car can drive, a book can be opened and can be read. Today we're going to give our objects abilities. We're going to add functions to our classes. These special functions are called methods. Now, a method is simply a function that is part of the class. It defines a behavior or an action that an object created from the class can perform. So if the attributes are the nouns of an object, like what it has, then methods are the verbs, what it can do. Let's go back to the car class and give it some life. Now, first let's add a mileage attribute to our cars. So it makes sense for every new car to start with 0 kilometers on the clock. So we can set this directly in our init method. The default attribute. Maybe let me just make a comment. Now let's add some methods. Just like with the init, the first parameter of every method must be self. Right. So this is how the methods can access the object's own attribute. So let's go ahead and create a method to describe the car. So I think I can remove this, and then somewhere here we'll add a method. So this returns a neatly formatted description. So this method doesn't change anything. It just reads the object's attribute and just gives us back a nice string. Now, for the method that actually changes the object state, let's create a drive method. So this modifies the object's own attribute. Notice how we call the self.getDescription from inside another method. This is a great way to keep your code organized. So the most important line is the self.mileage. So this one is actually the most important line, because the method is just reaching into the object it belongs to and changing its own data. Now, how do we use our method? So let's see this in action. So we can call methods on our objects using the same dot notation that we used for attributes. Suppose somewhere here, so we're gonna be calling the method now. So we can just say full name. Is car1 dot get description. Now let's call the method that changes the object's state. So we have the initial mileage, and let's say a car1 dot drive 250, and then they come back and car1 drives dot drive 75 kilometers. And we can just print now the current mileage. Alright, so what I can do, I can just copy this line here. And then for car2, let's just make, for car2 we can just print a line as well. Let me just put that line somewhere here. All right. So when we call car1.drive, it only updates the mileage for car1. The car2 object is completely unaffected. So this is the power of self. It ensures that the method only ever works on the specific object it was called on. Now we can go ahead and have a look here. Oh, so I need to actually cd to OOP. And then we can just run this. Then we can actually see now that the initial mileage was 0. But then we went and called the method drive, we drove 750. Then we went again and called the method drive 755. Now the current, actually must, so car 2 is still 0 because we haven't driven it. Alright. Now you now have the complete picture of the basic OOP, bundling data, attributes, and behavior methods into a single reusable blueprint class. So this is a massive step in your journey to becoming a professional developer. Next time we'll start using these skills to interact with the outside world. We'll learn about APIs and how to write Python code that can talk to the internet.